All right, this is part 3 of lesson 8.3. So now we're going to look at standard deviation, and this is just another measure of data spread. Okay, but specifically, it is the average of the distance, numerical distance, that is, not an actual distance, the distance between individual data and the mean. So it's how far away are all the data points individually on average from the mean. So let's start here. Find the standard deviation of these values. 77, 86, 84, 93, 90. So first, we find the mean. So we add all of our values together. Divide by how many there are. There's 5. We get 86. All right, so this is our average. This is our mean. Here are our data values. Now we will subtract each data value from that mean. 77 minus 86. 86 minus 86. That one's with the mean. 84 minus 86. 93 minus 86. 90 minus 86. And you can see here we get -9, 0, -2, 7, and 4. Then we take, these are the deviations, then we take each of these deviations and we square them. By squaring them, it won't matter if they're positive or negative. So -9 squared is 81. 0 squared is 0, -2 squared is 4, 7 squared is 49, 4 squared is 16. Now we can find the mean of the squared deviations. So now we take all those deviations, 81 plus 0 plus 4 plus 49 plus 16, and we divide those. There's 5 of them. So we got 150 divided by 5, which is going to equal 30. Okay? So there's our average. There's our mean of the squared deviations. Now we have to take the square root of that mean, and that is the standard deviation. So we would take the square root of 30, and that's going to equal 5.47. So 5.47, this represents the average distance between data and the mean. So that means on average, each of these data points, let me pull this up, sorry. On average, each of these data points is 5.47 points away from the average of 86. Okay, not all of them are that far, but on average, that's how far they are. So now let's look at this next example. Find the standard deviation of this data. First thing we need is the mean. So I'm just going to calculate that quickly. The mean, if I add all these values up and divide by how many there are, which is 1, 2, 3, 4, 5, 6, we get a mean of 26. And so now I take each and every one of these data points and subtract 26 from those data points to find the deviation from the mean. And here we've got -5, -2, 0, 0, 2, and 5. Then square each of those values. -5 squared is 25. -2 squared is 4. 0 squared is 0. 0 squared is 0. 2 squared is 4. 5 squared is 25. And now I can add all of those values up. 1, 2, 3, 4, 5. There are 6 of them. So I'm going to take 25 plus 4 plus 4 plus 25. Notice I left out the zeros. We don't really need those, but we do need to count those as quantities. So there are 6 altogether because those zeros count. And so now that gives me 58 divided by 6, which equals about 9.7. And now I take the square root of 9.7 and I get 3.1. So 3.1, this is the average distance each of these values are away from that mean. If you look, it kind of makes sense. Our mean is 26, and we have numbers like 24, 31, 28, 20. These numbers, yeah, they're on average, they're 3.1 places away from that average. And so the standard deviation gives you that indication as to how far away all of your data is on average from that middle. This is a good indicator because the bigger your standard deviation is, the more spread out you know your data is. The smaller this number is, that means your data is all very close to the mean, and that's a really good sign that you're getting consistent results over and over again. So for example, this standard deviation of 3.1 is better than this one up here of 5.47. These averages down here of 3.1, these are closer to their average than the other example that we looked at.